So I'm Kate Franz, and I'm the program director for the Organ Preservation Alliance. And let's see here. I wanted to start with this quote: "The loss or failure of an organ or tissue is one of the most frequent, devastating, and costly problems in human healthcare." And this was written by Robert Langer and Joseph Vicanti in an article for Science magazine 25 years ago. And unfortunately, what we see today is that this still holds true. And this is a problem that, in part, was the impetus behind the formation of the Organ Preservation Alliance, or OPA. So OPA was founded 4 years ago on this campus in the Global Solutions program and Singularity University. And they were challenged to identify and work on a technology that fit two criteria. The first was that the technology had to change or save the lives of 1 billion people in the next 10 years, so small feat. And the second was that it would just require a relatively small group of individuals to make an impact in that space. And so they settled on this idea that the world is built around being able to adequately store all sorts of things: money, energy, food, but there's no way to store life-saving resources like tissues or organs. And they thought this has to be a really significant bottleneck in medicine. And this is what we found, but the problem of organ preservation actually spans transplantation or surgery. As we've seen today, this is a problem that we identify as holding us back in research, drug discovery, and tissue engineering. Because if you can make a tissue, it doesn't really do you any good if you can't store it anywhere. So we're not the only people to identify this need. MATES, the Multi-Agency Tissue Engineering Interagency Working Group, in their strategic plan identified the tissue preservation as a critical bottleneck in tissue engineering. And then 10 years later, in a meeting with New Organ Alliance at the White House, Tom Khalil also echoed the sentiment. And more recently, the Institute Biofab USA, which was founded to catalyze the large-scale manufacture of engineered tissues, identified tissue preservation as one of their strategic priorities. Okay. And so the need for organ replacement is vast. Although there are only 100,000 people on the organ transplant waiting list, the deaths that are attributable to organ impairment are close to 1 million a year. And so if tissue engineering were successful and we could prevent many of these deaths, this would have a bigger impact on human health than curing all cancer. So if you want to learn more about what I'm presenting today and what I'll continue to present, we recently published a perspective article in Nature Biotechnology, along with 40 co-authors, some of whom are here today at the summit. And I encourage you to check this out. Our vision is to overcome the barriers of tissue engineering using preservation. Now, preservation includes a constellation of technologies from ex vivo perfusion to high sub-zero storage. And in particular, there's a lot of momentum building behind cryopreservation. So cryopreservation can control and effectively stop biological time. And this allows us to extend preservation of tissues and organs from days to months, years, maybe even decades. And we've already seen fundamental proof of principle that we can scale from cryopreserving cells to whole organs for clinical use. So in the past 30 years, we've seen advances in the ability to cryopreserve cells, to embryos, to tissues. And more recently, we've been able to cryopreserve and transplant rat hind limbs. We've been able to cryopreserve rabbit kidneys to negative 140 degrees Celsius and then transplant them in. And we've also been able to cryopreserve whole sheep ovaries that, when transplanted into a sheep, produce viable offspring. So these advances in preservation are also highlighted in our Nature Biotechnology article if you'd like to see more that's occurring. So how will we reach these goals? So together with our sister organization, New Organ Alliance, we built a community of researchers and broke down the problem of cryopreservation and tissue engineering into a series of 6 tractable sub-challenges. And these findings were published in a report along with multiple agencies, the NIH, NSF, DoD, and NASA, that was capped off with a White House roundtable on developing off-the-shelf organ replacement. And so New Oregon continues this work. This meeting is an extension of that work. And over at OPA, we've also been very busy. We recently held our first Global Organ Banking Summit at 2015 at Stanford. And then this summer, we held our second Global Organ Banking Summit at Harvard Medical School. We've also worked with government agencies to launch the first ever funding pipelines focused on organ banking. And the response to this was so strong that a second set of grants were funded before any progress or was reported from the first group. And ultimately, this led to the funding of dozens of labs. And so through this work, we found that organ preservation affects millions of people, and as such is under the purview of a wide breadth of prominent stakeholder organizations. And we've been able to collaborate with a large range of these, from very basic science-focused organizations to clinical and professional societies and organizations. And what this is all building towards is creating an ecosystem of labs of researchers, clinicians, different stakeholder organizations coming together to collaborate and work on these interdisciplinary problems in preservation. And so we like to think of this as like a 21st century Apollo program. And so it's going to be, and it's also supported by a wide variety of funding sources. And so as an example of this, OPA is committing $1 million of its own money to be used as a matching commitment in raising $5 to $10 million with our existing philanthropic network. And we're going to take this money and seed one or more organ banking research centers in the US. And we're also going to be providing the infrastructure to help them grow and scale to tens of millions of dollars. And so these centers are going to focus on cryopreservation and the existing multiple synergistic technologies. And we want to make advancing tissue engineering a priority. So this is our call. We're looking for models of organ systems that are cheaper than an animal model, are scalable, and could eventually be mass produced. So if you have any ideas or you want to become more involved, come talk to me, come talk to Jed, who is our president and CEO over here, and we'd love to talk to you, and I'm really looking forward to our breakout session, so thank you.